One, I think there's a couple questions that are a little difficult, so I'll go through and kind of explain each one. So for the first one, it gives me CE, this is a parallelogram, CE and EB, which are half the diagonal. Diagonals are split, it's bisected, so they're equal to each other. I have to find CB. So when I plug it back into either or, you're doubling it. Or you could plug it into both and add them together. You would get 34 for CB. For the angles, this gives you this whole angle right here, and it gives you this whole angle right here. So it's not just the skinny piece, it's the whole thing going all the way through, and this one's going all the way through as well. Because one's acute and one is obtuse, they are adding to make 180. They are supplementary. They are not equal to each other. So you should get 11. For 3 and 4, it's a rectangle. So P to R is a whole diagonal. S to Q is a whole diagonal. They're equal to each other. You get 7. When you plug it back in, you're looking for TR, which is a half of it. So I plugged it in and I divided by 2 because the whole thing is 26. When I divide by 2, that makes 13 for the just half of it. For this problem, PSQ is this portion right here. The other one, PSQ is here. PQS is here. Either way, if you look, they are not the same. This one is smaller, this one is bigger. They are not equal to each other. Using alternate interior angles, I can jump across the transversal and bring it down here. So these two angles are congruent. So that makes the corner adding to make 90. So they are complementary. So 90, I get 14. I have to plug it back into PQS. So 14 plus 5 is 19 degrees. The rhombus problems, it tells you NK is 7. It tells you KL is 15. So 7 and 15, that is the hypotenuse because this is a right triangle. So you're trying to find either A or B. It doesn't really matter which one you call it. But when you find that, you get 13.3 using the Pythagorean theorem. Then we're talking about angles for rhombuses and squares. They create angle bisectors. So it's giving me the two angles that are directly next to each other. And what I know about them is the diagonal is splitting it in half. So these angles are equal to each other. So when you set them equal to each other, you get 8 as your answer. For squares and rhombuses are very similar. So YZ is 20. WZ is also 20, 20, 20. It goes all the way around. To find the diagonal, because if this is 20, this is 20. To find the diagonal, you're doing the Pythagorean theorem to find the whole diagonal. And then you want to know just the piece of it, the small piece. So I take that and I'm dividing by 2 to make 14.1. The angle problem gives you just this little tiny side, not the whole thing. The whole thing would make 90, gives you just half of it. Half of 90 is 45. So you could either set this equal to 45, or most people were doubling it because there's two angles and they add to make 90, which is the corner. Either way, you would get 4. The last couple are just fill in the blanks. So isosceles triangles, the legs are congruent. So these pieces are congruent. The diagonals are congruent. Base angles at the bottom and the top are congruent to each other. Opposite angles, so this one and this one are not the same. Opposite angles are supplementary, meaning they make 180 degrees in total.